Hi and welcome to another Unity tutorial. In this tutorial I'm following on from the previous one which is showing you how to sync the transforms of a sprite across a network application. This time we're going to look at rigid body and what the difference of syncing the rigid body and syncing the transform is. So I've got the same project that we had before, except on the prefab for the sprite I've also added a rigid body 2D and a circle collider. So I just added that. I didn't change any of the values. And I added the rigid body and I turned the gravity scale down to 0 so that it wouldn't fall to earth, basically. Now the other thing I've done also is in the flip code, if we just go in and have a quick look, is you'll see that instead of having a rotate, I've translated the object. So we're going to have the sprite moving left and right across the screen. So you can actually have two sprites and they can bump into each other. It's the best way, I guess, to demonstrate the physics that's going on. So the left key is going to translate in the negative X and the right in the positive X. Okay, so let's build this out and have a look. So in the editor's client version, I will host it, and in the other one that I've built out externally, I will start a client. Now when I move the client, here he is here, and I go over and hit the server's character, you can see that it does collide and it does push the other character, albeit not as nicely as a rigid body would, because we're actually using transforms in this case to move it. So that's using the transform. And if I go back into Unity and we just have a look at this little green monster guy, in his network transform component, the transform sync mode is set to sync transform. So what's happening over the network is that the transform data is being sent back and forward. The difference with that and having a rigid body is that the rigid body is actually going to be send information about the rigid body, which is also going to include velocity and force type values. Okay, so you're going to get a completely different result. So in order to sync and move a rigid body around, instead of using the transform code that we've already got in the flip here, we actually have to move the rigid body, not do a transform movement. So this code in flip will have to change. And we change it to this. So first of all, I'm going to create a variable to hold on to our rigid body 2D at the top here. That just makes, I guess, the typing a little bit less later on. Not that there's much to be done in this code anyway. And then we have pick this rigid body, picking up the rigid body 2D component that is on our character. And then in the update, we're going to use the horizontal get axis key, which will pick up the left and right arrow keys, and multiply that value by 0.1 just to make it a little bit smaller, because as you start using this as the movement for the character, it'll move quite fast. And then instead of use our transform.translate, we're using rigidbody.movePosition instead. And we're moving the position of the rigid body from its current location and adding on an X direction vector, okay, so a horizontal vector, and multiplying it by the translation. So this translation will be positive or negative depending on the arrow key that's being hit, which is going to move the character back and forward. Right, so save that, and then back in Unity we want to make sure that on our character we've got our sync rigid body 2D set for the network transform, and then we're ready to build it out and run it again. So let's start our client and start our server, or the other way around I should say. Right, so we'll get the client's character. Now you can see the movement already, how much smoother it is. Before with the transform, you're actually sending the transform information over the network, and it doesn't happen like all the time. So you can't send every single transform position across the network. Otherwise, it's just going to clog up the system. So your character will sort of jump from one position to the other. It's not a smooth transition. With a rigid body, the rigid body has a force and a direction that it's going in. So therefore, Unity actually can interpolate the position of the character for you. So while it's not getting any network messages from where the other characters are, it can interpolate, or it can guess or guesstimate, I guess, with mathematics where exactly it should be. And also now, if I take a little bit of a run up and we hit this other character and collide, it will actually react in the physics. And you can see I'm not controlling that. He actually went off the screen of his own accord because of the physics on that character. Okay, so they're the difference between syncing a transform and syncing a rigid body. And also make sure that if you're going to sync a transform, that you use the old code, not this one, so the one that was using transform.translate. But if you want to move a rigid body over the network, then you actually need to move the rigid body with the rigid body code. Even though using the translate code would still move the character, it wouldn't be using the rigid body to move the character. And that's what you actually want for smooth movement. All right, so that's the end of this really short update on this tutorial. Again, if you're interested in learning more about Unity and Unity's networking, please visit my Udemy course online. Thanks for watching.